Hello everybody. Today we're going to go over some of the requirements for doing our lab work this year. So we don't do formal typed up lab reports, but we do a lot of lab work. Some of it you do before the lab, some of it you do during the lab, and some of it you do after the lab. In your binder, you do have a very detailed list of all the expectations and all the requirements. It's really important that you read it and you're familiar with it. This presentation is me trying to emphasize some of the really important parts and some of the parts where we see the most mistakes on the first couple of lab assignments. We don't often have time to go over it in detail during class, just due to the calendar. There's never enough days. So my hope is that while yes, you are expected to read the document in your binder, that this might be a really good, helpful supplement to that, trying to just emphasize a few things for you. So we're going to start by talking about Prelabs. And the way I've set this up is that we're going to do Prelabs first. Those are due before the lab starts. That is a safety requirement. You cannot participate in a lab if you are not prepared for the lab. If you don't know a chemical is dangerous or you don't know how to treat it if it spills on your skin, that's not going to be okay, right? We have to keep you safe, and that requires a little bit of preparation. This will be done in your graphing notebook. During the lab, you're going to collect your data, you're going to collect your observations, and those will also go into the lab notebook. You have to finish your lab during class. There are no passes to be late to the next class. The labs are all designed to fit within the period. If you are not finished on time, that means that you did not come prepared enough. You have to truly know what the procedures are. You have to get to your lab station and you have to start working immediately. You do not stand around and chat with your lab partners and kind of go, I didn't really do it. What about you? Do you know what the first step is? I don't know what this piece of equipment does. That's all going to waste time. You must come prepared. Once the lab is done, we do what's called the Postlab. This work is also done in your graphing lab notebook. It will have a due date posted. It could be due the very next day, it could be due a couple days later. It just depends on the calendar and what else we're doing. Instead of doing the very formal typed up lab reports like we used to do, what we do now is a simplified version that's done by hand. I went through and tried to pick out the most important parts of a formal lab report and figure out how do I fit these onto a two-sided worksheet. So you will be going through and doing certain sections that you might see on a traditional lab report, like error analysis, for example, but you will just be putting it by hand onto a worksheet. That way we get the perks of learning about those types of sections. We're going to be able to talk about our sources of error in a really good way. We're going to really be able to learn all the things we need to learn without wasting time typing up a 10-page lab report. Okay? Couple of general requirements. Only black or blue pen. You cannot use pencil. You cannot use erasable pen. You have to understand that lab notebooks are technically considered like a legal document, right? Where they could be brought to court sometimes for companies, right? You can't be altering your notebook. We have to make sure that we are keeping an authentic notebook in pen. I am completely fine if you want to use some colors to annotate what you're doing. If you want to do your procedure in mostly black, but you want to add a little bit of color here and there, completely fine with me. But the bulk of it needs to be in black or blue pen. Big deal is if you make a mistake, you have to cross it out with a single line. We never, ever, ever use whiteout, and we never scribble something out. You must be able to read what was there originally. If you make a huge mistake and you want to cross out an entire page, that's completely fine. Just do one big diagonal line across the entire page. but never scribble and never use whiteout. All right, these are all bullet points that are coming directly from the document you have in your binder with all the expectations. What I'm going to do is go through and highlight and pick out some key things. Okay, so for Prelabs, like we discussed, done in our notebook, you will either turn your notebook in physically or you will submit photos on Google Classroom typically, or you might do both. It depends on the year. You will be told what we're doing each time. If in doubt, always bring the physical notebook. Prelabs have to be done before you start the lab. That is not negotiable. Okay, it's a safety thing. If you didn't upload your prelab on time, you won't get credit. You will have to use a late pass if you want to earn credit for it. But as long as it's finished before you get to class, you can show me your notebook and show me it's finished, and you can participate in the lab. You won't earn points for it because it was late, but that means I will allow you to participate in the lab. If it's not done, you're going to have to sit in your desk. You're going to have alternative work to do. Afterwards, you will have to get the data from your lab group and you will have to do all the post-lab work as if you had participated. It is not practical to make up the labs. You just forfeit the opportunity. You will need to get the data from your lab group. You are not exempted from doing the post-lab just because you didn't do your pre-lab. When you do your pre-lab, we don't have to do every section every time. Some of them are not applicable. So the top of your lab handout will tell you which sections to do. Do not do extra sections. Only do what's asked, because if you do an extra section, it's showing that you do not understand the material well enough to understand that that doesn't make any sense. If we're not doing a lab where a hypothesis makes sense, whatever you write for a hypothesis shows a lack of understanding. So extra sections are not good. Please do them in the order listed in your document, in your binder, unless your lab handout says otherwise. I've tried to make them consistent, but sometimes things slip through the cracks. The sections need to be very clearly labeled. You have to understand I have 170 students some years. It's really important that things are labeled. I have to be able to grade things quickly so that you can learn from your mistakes quickly. There will be what are called headers. It will tell you in your reference documents and in the sticker inside your lab notebook cover how to fill out a header. It's basically you telling me the name, your class period, what station you're at, what's the name of the lab, things like that. And then this is another part that is about keeping an accurate lab notebook. You need to number the pages. Oops, I went too far. You need to number every page in the bottom outside corner, and you need to initial and then circle your initials in the bottom corner. That's really important because I need to know that every page was done by you. It's how we make sure there's no missing pages, things like that. You're signing your lab notebook on every page. The header you only do once at the beginning of the lab. The initials and the page numbers are every page. Sometimes I grade it for completion. Sometimes I grade it for accuracy. Sometimes I'll only grade certain sections. Sometimes I won't grade any of it. It just depends. Unfortunately, the reality is if I have so many students and there's only so many hours in a day, I have to be thoughtful with which assignments I grade. I have to decide what's going to be the most benefit to you, the most representative of the work for the course in your grade. But at the end of the day, at some point I do have to go to sleep at night, right? So I may not be grading everything. You will not be told ahead of time because the expectation is you do all the work no matter what. You're here to learn. You're not here just for what's in the grade book. This is a big one. Professionalism matters. If you had an English project or a social studies project you were supposed to spend a long time working on, it's an important assignment, you wouldn't get up and do your presentation with a piece of binder paper and a pencil drawing, right? You would have put some effort into it. I want to see that in your lab work as well. If I can't read it, I'm not going to give you points for it. You need to be making sure your lines are straight. Get a ruler if you need to. Okay, do what you have to make it professional looking. You need to leave decent space in between the sections. I cannot grade a notebook that is just jam-packed together, okay? I need space. I need to be able to see what's happening. I need to be able to find the sections. Communicating your ideas includes being able to find them, okay? If you run out of space, I'll get you another notebook. It has never happened. No one's ever run out of space in their lab notebook. So the sections, we have a purpose. Sometimes it might be a goal. Sometimes it might be a question. You want to describe the actual chemistry concept, right? We're trying to connect it back to the chapter and back to the topic that we're actually learning about. We're not just describing the lab, okay? We're trying to say what we're actually supposed to be learning. You do want to include the specific results. So you would say something like, in this lab, we are trying to determine the specific heat of brass by using calorimetry and the Q equals MCAT equation in order to solve for specific heat. I'm talking about the general chemistry principle, I'm talking about the technique that we're using, and I'm talking about the specific results we would be obtaining. The hypothesis, we almost never do this. Hypothesis is not super practical for our level of chemistry. Once in a while we might. We must do it before the lab starts. You can't backwards plan hypothesis. You can't do it after the fact. This is what you're trying to guess before the lab starts. We often have a very oversimplified perception of what a hypothesis is. A hypothesis needs to have certain parts to it. You have to have an if, a then, and a because. Example, if I add fertilizer to the soil, then the tomato plants will grow taller than the plants without fertilizer because the fertilizer has extra nutrients to promote growth than the control sample has. Now, it doesn't have to have that exact format. You don't literally have to use if, then, because. But the if is talking about what you're going to be doing. Then is whatever the results we're going to see. And the because it's what makes this a hypothesis. It's the scientific reasoning that you have for what you think you're going to see. Otherwise, you're making a random statement and you're making a random guess. And we don't do that here. We have to connect it back to the theories of chemistry. The because is huge. This is where you show me that you've been paying attention in class. This is what our lessons have been about. Most of the prelabs will have prelab questions. You need to answer them all completely. Please number them. Show all your work if there's any calculations. I do not want you to copy the question. We don't have time for that, but I do want the question paraphrased into your answers. If I forgot what question 4 was, I should be able to read your answer and it should jog my memory. I should be able to figure out what the question was. You don't necessarily need full sentences, but you do need complete thoughts. You do need to have detail. You can't just write 2 words. You can't just say increase, for example. I need more than that, but I don't need beautiful, amazing, page-long essays. If there is a very explicit answer like a number or a single word, then you would box anything final, any short phrases, things like that, that might be helpful for me when I'm trying to grade 170 of these lab reports. The materials section is the only section that you can copy from the lab handout. It is just a list. Bullet list is fine, not a problem. One thing to be cautious of, though, is that you include any concentrations or states of matter. That is a safety thing as well as a practical need. For example, the safety information for a solid might be very different than the safety information for something that's aqueous. Something that is 0.1 molar is going to be a very different level of safety than something that's 12 molar. The reagent table is often everybody's least favorite part of the pre-lab, but it is the most important part to keep you safe. You have to make sure that the dangerous chemicals are included in your reagent table. I tried to put a little star next to them. Sometimes those stars are small, they're hard to see. It would be instead of a bullet point, you would see a little asterisk. If in doubt, include it or send me a remind message and ask. Some labs, if it looks like there's nothing starred, ask me. Maybe it's a typo or maybe it's on purpose. You include the states of matter. You include safety and cleanup information. Once upon a time, we used to have to look all of this up in a literal book. You don't have to do that anymore. It's all online. I've linked in your handout one that I like that's free from our chemical company. But if you Google MSDS, which stands for Material Safety Data Sheets, you'll be able to find lots of free ones. Please don't ever think you have to pay for this resource. There's tons of free ones. The people who are paying for this are simply paying for an interface that they might like. They might like the format. They may like how the search bar works, things like that. Don't worry about it. Find something free. And please don't squish your safety table. It's really important. And don't do it last minute. I have to keep you safe. You have to keep yourself safe. There is a sample table provided to you. You will need to change the size of the boxes to be appropriate for whatever it is you're recording that day. This is just a sample. Yours might be really big, it might be really small, one row might be bigger than another, but these are the sections you would include. Procedures are done differently in my class than most classes. It is not simply rephrasing the steps in a bullet list or numbered list. This is going to be you trying to really process and really think about the steps and reformat it in a visual flow chart, right? Little boxes and arrows and things like that, comments off to the side. You're going to include drawings and things like that, okay? Because we need to make sure we get this information into our brain. Paraphrasing a procedure into the same numbered step format, that does not register in our brain the same way. Okay, so I want to see it in a flowchart, highly visual manner. Don't combine the steps. If it's number 4 on my handout, it needs to be number 4 in your lab notebook. If there's any changes to the procedure, I need to be able to tell everybody, all right, everybody, step 4 is going to be different this year. Please alter your notebook. Step 4 this year is going to be like this. Okay. Got to get those visuals in there. Pictures of the lab equipment. Draw them, sketch them out. Use labels. Draw your setup. Reminders, equations, things like that. You should be able to do this lab with nothing but that notebook. You should not have the lab handout on your station. You should come prepared enough with your notebook that you can walk in there safely and just get it done. Data tables. You have to set up your data table before the lab starts. You need to think about the things you want to record. You need to think about how much space you will need from them. You need to make sure that it's all ready to go so that you don't waste time in class. Okay, has to be all the required parts. We need to have all the different types of data, quantitative and qualitative. You will always have qualitative data. You might not have quantitative data. It depends. Make it big enough, right? It doesn't have to be gigantic, but I don't want anything squished. Giving a descriptive title is one of our biggest problems. We have too many people writing bad titles. Telling me it's your data table is not helpful. Telling me it's data tables of temperature, right? Data tables for my lab. Those are not going to be good. If there is a specific reaction, it should show up in there, right? The effects of concentration on absorbance, or pH of common household substances. Temperature change for the reaction of magnesium chloride and sodium hydroxide. Those are good data table titles. You got to have labels and units. Sometimes people don't realize those are different. The label is telling me what you're recording, and the unit is the increment of size that you're doing, right? So if you are going to be taking the temperature, it would be initial temperature, Celsius. Final temperature, Celsius. Be mindful of your sig figs. You want to write down all the numbers given to you on something like your scale, but when you go to do your calculations, you may not be using all of those decimal points in the end. You have to round your answers during the calculation section, not when we're writing down our data, okay? So please record all the decimals, deal with the sig figs later. The qualitative observations need to be viewed as important. We cannot be just writing it changed, it reacted, it looks different. You got to be very descriptive, please. Your data tables should be created already, and you fill them out during the lab. They are part of the pre-lab work, but they are also part of the post-lab work. I have to see them both times. And I'm going to be looking for all the things. Okay? If you messed up your data table title on your pre-lab and you lost a point, fix it. When I grade your post-lab, I'll give you a point for the post-lab. You won't earn the point back for the pre-lab. That one's done. Sorry, it's locked in. But I don't want you to lose the point again, right? So fix your mistakes on your data table before you turn in your post-lab. Not all labs will have calculations. If there are calculations that it'll tell you, you'll have a section for it. We have a lot of people who are leaving out calculations because they think they're simple, like subtractions or additions or multiplications, etc. Include any manipulation of your numbers. Every once in a while, one of your answers will get put into your data table. That's fine. It can be in your data table as a final answer, but I need to see the calculation in the calculation section. And like I said, make sure everything's included. Number things to match. Make my life easy, please. Also, make sure I can follow what you're doing. Label your calculations, right? When I'm grading 170 labs and everybody does things in a slightly different manner, it can be very challenging to follow what's called the flow of work. You need to label and make things clear. That is part of what you're learning in this class. Whether you go on to do chemistry for the rest of your life or not, being able to communicate and being able to get your ideas across to people in written form is super important. And the layout of that is part of it. Professionalism matters. It really matters. And units everywhere. Units, units, units. We don't have random numbers. They need to have a unit. After the lab, you will have post-lab questions. So number all your questions, just like the pre-lab. Don't recopy it, just paraphrase it. I don't need complete sentences, but I do need complete answers. If the post-lab question is a new calculation to do, sometimes I'll give you a new fake scenario, or, pretend that, a student is doing the lab and this is the data they got. What would their answer be? Anything like that, show all your work, sig figs, labels, just like you should all the other times. Lots of thought and lots of detail. The last part of our post-lab is what's called the post-lab 2-pager. This is a handout you will be given. You have an example copy in your binder from the reference section at the beginning of the year, but you will also be given a blank copy each time we do a lab. You will be doing this by hand. I do not take typed work. There are sections, Not all the sections are applicable every time. You might have a blank box. That's fine. That's not wrong necessarily. I'm not going to customize the handout for you, each lab, because one of the things I need to see is if you understand the material well enough to know what should and should not be included. Totally fine to use the same lab title as my handout. I don't need you to try to invent something creative, okay? If you do want to make your own title, it needs to be specific. The topic is something we sometimes struggle with. I usually see students who give me something too broad or too specific. Telling me the chapter is too specific. Telling me the topic is what I want and the chapter is too broad. The topic is just right and the subtopic is too specific. Telling me the topic would be thermochem. No, that's the chapter. The topic is calorimetry, and specific heat is something that you learn about and use when you do calorimetry. So hopefully you can see what I mean about we want that middle ground. Not too broad, not too specific. It's like Goldilocks. We want it just right. The nice thing about the Postlab 2-pager is some of it can come straight from your Prelab. You can use the exact same purpose, question, problem, goal, hypothesis, whatever you did in the Prelab, put it on the 2-pager. If you did it wrong and you lost points, you can fix it. It doesn't have to match. If you want to improve it, that's fine. Don't lose points twice. And we should just have one. If there's a purpose, you're not going to also have a question, right? If you have a question, you're not also going to have a goal. So just pick one. Pick the one that makes sense. Key vocab terms. You got to list them all. All of them. There's lots. Anything related to the topic. This is not just like the words you learned for the first time in the chapter. This is all the words you need to know to really understand this concept. Some of them might be words from Honors Chem. In AP Chem, right? It might be from the previous level even. Just a bullet list. You don't have to define them. The very interesting thing to me is apparently most of the benefit comes from listing the vocab words, not necessarily defining them. So save yourself some time. Don't write those definitions. Key equations. This is not you showing me doing the calculations. It's you telling me the equations you're going to use. Things like you're going to use Q equals MCAT or Q equals ML, right? Those are the kinds of things I want to see. Label it. If it has a name, use the name. There might be one, there might be several. Key concepts is where we tend to struggle because people will just do bullet points. This is the one place we need a full paragraph. Pretend you're writing a little mini textbook paragraph. You're writing a summary for a textbook. You want to squish in everything. Pretend we took a whole chapter and squished it down into one little box. Every single thing, lots and lots of specific things I'm looking for, those key points. I will not give you a list of what the key points are. Your job is to show me you know what they are because you've been learning all chapter long, okay? If you leave out something super important, gonna get docked a point, okay? So, for example, if we're doing calorimetry, you need to explain in your paragraph the energy is not created or destroyed, it's just transferred from one object to another. That is a very key point for calorimetry. If that's not included, I'm looking for it, you're going to lose a point there. And please don't tell me the procedure. You can talk about the specific techniques if they apply to the point of the lab, but I'm not asking you to tell me a breakdown of all the steps. For the lab equipment setup section, you're not just making a list, you're not telling me the procedure. Oops, these are out of order. Sorry about that. We want to make sure that we are showing me little drawings and descriptions of the techniques themselves. Calorimetry, for example. It's one of the best examples. Label your drawings. Tell me how something specific works. How does a burette work? Right? What's special about a burette? Or if we're using a spectrophotometer, what does a spectrophotometer do? The sig fig section. This is where you're going to, for each piece of lab equipment that you use, tell me how many sig figs were on that piece of equipment. A graduated cylinder is not going to have as many sig figs as my analytical balance. And then I need to know which piece of equipment limited my sig figs. I could have 10 decimal points on some super fancy piece of equipment, but if my graduated cylinder had 3 sig figs, I'm going to be limited by that, right? So we have to be careful to think about that. And please make sure you think about each piece of equipment. I have a lot of people who will forget one of the things that they used. They'll talk all about the scale, but they forget about the graduated cylinder. And when you do your calculations, remember, you will be rounding based on the sig figs used in the lab, based on the equipment. Experimental results should be the shortest, easiest part of this. Just tell me your final answer. You are not listing everything, okay? Not every single piece of data goes in here. This is not a little miniature data table. It's your final answer. The specific heat of brass was found to be, and then whatever the number is. Make sure you label, make sure you have units. If your result is not a number, that's fine, but be concise about it, okay? Accepted value, I will tell it to you. What's the correct answer? What should you have gotten? Sometimes I even will post these on Google Classroom. I might write it on the whiteboard. I might tell you at the end of class. It is okay if you didn't get the right answer. We have lots of sources of error. I am not personally the kind of person that wants to dock you for having like a bad percent error. The key is, can you explain why you had a bad percent error? Some labs, a percent error that's considered good might be a huge number. Not all labs work very well, okay? So it's just not something that's an easy thing to have a target for, okay? So it's okay if you're pretty far off, but you're gonna have to explain why you're pretty far off. The place you explain how far off you are is that error reporting section. Sometimes it's a percent error. Sometimes it might be a percent yield. It could even be a description. You won't have to do all of these every time. It depends on the lab. If it is a calculation, you must show the calculation. If it's not, you better be detailed. Okay, make sure you're descriptive. Possible lab errors is probably one of the hardest sections, but it's the most important section. Especially by the time you get to AP Chem, this is huge. This could be a big score difference on that AP exam, okay? They ask you a lot of things about this. Please number the errors so that you can easily refer to them in the next section. I want to see things that I know are errors based on our equipment, okay? We don't have perfect equipment. For example, if we're doing a calorimetry experiment, heat might escape out of my little device, out of my little calorimeter. Everyone in the room is going to have that source of error. Everybody should know that. Everybody should be putting that on their paper. If you leave that off, it means you don't understand the concept very well, okay? You might have lab errors that are unique to your lab table. Something specific happened at your table, that's okay. Include those. That explains your percent error sometimes. But there are ones that are what I call inherent to the procedure or the equipment. Think about the things that we could improve upon if we wrote a better procedure or we had better equipment, okay? Don't ever say human error. That's not a thing, okay? That's an instant 0. You write human error, you're getting a 0 for the entire section. It is incredibly important to understand that when students say human error, what they mean is I made a mistake. And if you make a mistake, you should have started over, okay? You don't put human error. You need to explain if something truly did happen. If you weren't able to start over, if there weren't enough chemicals, there wasn't enough time, you're going to have to explain what happened. But the phrase human error is an absolute no, cannot be said. Please also don't make up crazy, bizarre errors. You would be shocked, the things I see. For example, don't say someone could knock over their beaker if you didn't knock it over, right? That would be a mistake. You didn't make that mistake. Don't include that on your paper. Godzilla did not come and break your scale. We didn't have an earthquake that knocked everything over. One year I had someone say, Mrs. Farmer could have mixed up all the chemicals and given us everything wrong. I don't think that's going to happen, guys, okay? Please don't list crazy things. We want those types of errors that are inherent to the procedure, things that really happened, things based on our equipment, things that we can fix and work on to try to make it better the next time. And the next section is going to be really dealing with what would the result of these be? And then another section is how will we fix them? Okay, so you can't have your source of error be the reaction doesn't work well, right? That's the reaction we're doing, guys. How can we fix it? Maybe we use a better piece of filter paper, okay? Maybe we stir it for a longer time. And like I said, if you really did make a mistake, it's okay, but you're going to need to really explain it, and you probably should have talked to me to see if you should have restarted it instead. If you ever make an error where your data is truly useless, you can't even do the Postlab. There's no results. There's no data. There was no time to start over. You'll probably use data from another group, okay? Sometimes I have sample data, but I need you to come talk to me and we'll figure out what to do. This is the other really tough section, is the mathematical impact of lab errors on your results. The key here is tracking for every error, all the places things are going to be off. Imagine you are a frog trying to get across a pond. You're not jumping all the way across in one go. You are jumping on all the little lily pads along the way, little tiny baby steps. Okay, and you want to kind of walk through and explain how that would happen. I'll ask you to write an example test question. I want a good one. Okay, I don't want you to copy one of mine. I don't want you to copy it and just change the numbers. I want you to do this with the intention of the assignment. I want you to do this in a way that is going to get you the benefit. I don't want this to be busy work, and whether it's busy work or not is purely in your hands. If you try to take shortcuts, you're wrecking it for yourself. Okay, please think about that. I'm trying to see if you can predict the types of things I'm going to put on an exam. In an AP chemistry class, for example, I'm not going to ask you what's the molar mass of carbon. That's not representative of the complexity and the depth of the chapter we were on, okay? So please, please think about the complexity and depth of what you're doing. And then you got to solve it. Show your work, be detailed, use key terms and phrases, whatever you need to do based on the question. It doesn't have to be a math question. Okay, it could be a conceptual question, but then I want a super good answer. All right, I know that was so much. It's all in writing, so that's the good news. You can look at it 1,000 times. You could print off a new copy each time and cross things off, highlight it yourself. Feel free to mark up your copy in your binder. You go through and highlight things if you want, okay? You can rewatch this video 1,000 times if you really feel like it. So I hope it's helpful to hear my commentary because I doubt we'll have time in class for this level of detail. But the good news is it's all in writing. You are all going to be able to do a great job on these labs this year. Okay? Please, as always, ask me a question early. Don't wait until the day it's due or the night before. Don't procrastinate. Reach out for help. Send me a message, send me an email, swing by my classroom. I would love to help you do well on these labs this year. All right? Okay, everybody. That's it. Bye.